Welcome to Edexcel Maths, and today we're going to look at Chapter 4, which is Graphs and Transformations. The first thing that we're going to look at are cubic graphs. You need to know that cubic function has the form ax cubed plus bx squared plus cx plus d, where a, b, c, d are real numbers and a cannot be 0. Let's have a look at the shape of a graph when a is positive. The general trend of this kind of graphs is basically it goes from bottom left to top right. You would also know that when x is negative, y is also negative, and when x is positive, y is also positive. Similarly, if a is negative, the curve will slope from top left to bottom right. Vice versa, when x is positive, y is negative, and when x is negative, y is positive. And combined with the knowledge in Chapter 3, we get that the root of something is basically when y equals to 0. So y equals to f of x will touch or cross the x-axis at point P0. Let us look at an example of this, in which we have to sketch the curve y equals to x minus 2 cubed. And we'll try to find the root of it, which is when y equals to 0, and you get that x equals to 2. You will substitute x equals to 0 and you get that y equals to negative 8. From previous chapters, that when x equals to 0, we're trying to find the y-intercept, and when y equals to 0, we're trying to find the x-intercept. We also know that in this case, a is positive, so when x is positive, y is positive, and when x is negative, y is negative. Then you just have to plot the point of intersection onto the graph and draw it with the shape that we found. The next thing that we're going to look at are quartic graphs, which takes the form f of x equals to ax to the power 4 plus bx cubed plus cx squared plus dx plus e. And just like the quadratic graphs, a, b, c, d are real numbers and a cannot be 0. Let's look at a graph where a is positive. And we get this general trend where the graph is facing upwards. Similarly, if a is negative, then the graph will be facing downwards. However, unlike the quadratic graphs, in quartic graphs, if a is positive, x is positive, y is positive, x is negative, then y is still positive. Similarly, if a is negative, then when x is positive, y is still negative, and when x is negative, y is also negative. Let's look at an example in which we have to draw the curve y equals to x minus 1 squared times x minus 3 squared. First of all, you need to find the roots, so y equals to 0. And this equation is already factorized, so you know that x equals to 1 or 3 in order to get the result of 0. Then you want to find where the curve cuts the y-axis, so you will set x equals to 0 and substitute the value of x into the equation. Then you will get that negative 1 squared is 1 and that negative 3 squared is 9. So 1 times 9 is 9, then the y-intercept is 0, 9. And apply the knowledge we learned before. We know that the shape will be facing upwards as a is positive. Then you just need to label the points of coordinates that we found and join them together with a smooth curve. And that's it for this question. The next thing that we're going to look at are reciprocal graphs. First, you need to know the definition of an asymptote, which is basically a line that the graph approaches but never touches. And here is an example of an asymptote. You also need to know that the graph of y equals to k over x and the graph of y equals to k over x squared, where k is a real constant, will have asymptotes at x equals to 0 and y equals to 0. This is because the fraction cannot have 0 as its denominator, so it will have no solution. Therefore, they do not intersect the axis. Now let's look at the general shape of a reciprocal graph. If y equals to k over x and that k is bigger than 0, then the asymptote is going to occur on the top right and bottom left. And similarly, if k is smaller than 0, the asymptote is going to occur on the top left and bottom right. Two more graphs that you need to get familiarized is y equals to k over x squared, in which k is bigger than 0. You know that these two asymptotes will lie on the graph where basically y is bigger than 0. There is actually a reason behind this, which you know that k squared cannot be negative and that k is bigger than 0. So a positive number divided by a positive number will give a positive value. And vice versa, y equals to k over x squared, in which k is smaller than 0, will have its asymptotes lie on the values where y equals a negative number. This is because the denominator x squared is always a positive number, and now k is a negative number, so a negative number divided by a positive number will always give a negative number. Now let us look at an example of this, in which we have to draw the graph of y equals to 4 over x squared and y equals to 10 over x squared. You would immediately know that this graph will have its y-axis to be all positive. After doing many questions, you will get a general idea that the bigger value the numerator is, the further away it is from the axis. Now we're going to look at how to find the points of intersection given the equation of two curves. If the coordinates at the point of intersection of the curves with the equation y equals to f of x and y equals to g of x are the solutions to the equations f of x equals to g of x. Let's look at an example. We can see that we need to find the points of intersection given these two equations. So what we will do next is to let these two equations equal. Then we will multiply out the brackets and move x squared and negative x cubed to the left. So we'll leave the right hand side to equal to 0. Then we'll be able to take out x. Then we know that either x equals to 0 or x squared minus 3 equals to 0, so x squared equals to 3. So you know that x equals to 0 and square root of 3 or negative square root of 3. Then you just need to substitute the value of x into the original equation to get the value of y. Now we're going to look at transformations of graphs. The first thing that we're going to look at are translation. Adding or subtracting a constant outside the function translates a graph vertically. However, adding or subtracting a constant inside the function translates the graph horizontally. But this does the opposite. Let's see what I mean. If a is positive and a is added inside the bracket, the graph is going to move a to the left. And this can be represented by this vector. Let's look at an example. Given that f of x equals to x cubed, we have to sketch the graph of y equals to brackets x plus 1. We immediately know that we're going to move the graph 1 to the left. So first we're going to draw the graph of y equals to f of x, then translate it 1 to the left. And in order to find the intersection with the y-axis, we will let x equal to 0, and you know 0 plus 1 is 1, and 1 cubed is still 1. Therefore, the intersection with the y-axis is 0, 1. You also need to know that when you translate a function, any asymptotes are also translated. Let's look at an example, in which given that h of x equals to 1 over x, and we have to sketch the curve with the equation y equals to h of x plus 1. From the equation, we get that this is going to move 1 up. Therefore, we would first sketch the curve of y equals to h of x and move it 1 upwards. The next thing that we're going to look at are stretching graphs. You need to know that the graph of y equals to af of x is a stretch of the graph y equals to f of x by a scale factor of a in the vertical direction. Just think of it like this. If the value of x remains the same and the function is multiplied by more times, then you will get a bigger value of y. if y is positive and a smaller value of y if y is negative. Therefore, we will see a stretch of the curve in the vertical direction. However, the graph of y equals to f of ax is a stretch of the graph y equals to f of x by a scale factor of 1 over a in horizontal direction. And let's visualize this on a graph. You can observe that the bigger value of a, the more squeezed up the graph is going to occur. The next thing that you need to note is the graph of y equals to negative f of x is a reflection of the graph y equals to f of x in the x-axis. You can actually try to understand this instead of memorizing it. Just think of it like this. If x is positive and the function is multiplied by a negative number, then y is negative. But before this function, y was not negative. So y is translated in the horizontal axis. And similarly, the graph of y equals to f of negative x is a reflection of the graph y equals to f of x in the y-axis. And this is because before x was positive and now x is negative, so it is translated in the y-axis. And that's the end of chapter 4.